Okay, so let's dive right into this explainer and demystify exactly what Docker is and honestly why it has completely revolutionized the tech industry. Whether you're a seasoned software engineer or maybe you're just stepping into the tech world, you have absolutely heard the buzz around containers. So today, we're going to break down the actual magic behind Docker, figure out how to escape what's known as the matrix from hell, and get you ready to actually use it.
But first, have you ever spent days painstakingly configuring an app, getting every little thing perfectly tuned, only for it to completely crash the second you run it on someone else's machine? Yeah, it's the ultimate developer frustration, the dreaded "well, it works on my machine" syndrome. It's totally maddening, right? Well, that exact frustration is where our whole story begins. Part 1. Escaping the Matrix from Hell. So imagine trying to set up an end-to-end application stack. You've got a web server running Node.js, you've got a MongoDB database, maybe a messaging system like Redis, and you're orchestrating the whole shebang with Ansible. Sounds great on paper, right? But then the compatibility conflicts hit. One service needs a specific OS version, while another one requires a completely conflicting older library. This massive, tangled mess of services, libraries, and OS dependencies is what the industry famously calls the matrix from hell. For a long time, it made developing and shipping apps an absolute nightmare for teams. Part 2. What exactly are Docker containers? Let's look at how Docker brilliantly solves this matrix problem. Instead of installing everything directly onto your bare system, Docker packages your application and all of its dependencies tightly together into one neat, self-contained box. Because these isolated environments share the underlying operating system kernel, like Linux for example, it means they're guaranteed to run exactly the same way on any laptop or test server or production environment. You literally just type a single Docker run command and boom, you are up and running. Oh, and a fun little piece of trivia for you. While Linux containers have actually been around for a while, Docker is what modernized the whole ecosystem, shifting away from older tech like LXC and standardizing on super robust tools like Containerd and runC. Now, to really understand how this works, we've got to nail down some core terminology, starting with an image. Think of an image as a read-only package. It's like a blueprint or a template. If you've ever used virtual machines, it's very much like a VM template. You can have a base image for Ubuntu, an image preloaded with an NGINX web server, or one just for a database. Basically, it's the static file that holds everything you need to generate your environment. And that leads us directly to the container. A container is simply the completely isolated running instance of that static image. It comes to life with its own environment, its own processes, and its own network interfaces. But, and this is a vital thing to remember, a container is ephemeral. It's designed to only live as long as the process inside it is running. The second the task is done, or if the web service crashes, the container just stops and exits. Part 3. Containers versus virtual machines. Let's compare them, because this really illustrates the difference. Traditional virtual machines are heavyweight. They require a hypervisor and a full, entirely separate guest operating system for every single VM you spin up. That means they can take agonizing minutes just to boot. Now contrast that with Docker containers. Because they cleverly share the host's OS kernel, and they only package what the app actually needs, they boot up in a matter of seconds. It is a massive leap in efficiency. Although it's not always a competition. In really massive enterprise deployments, you'll actually often see thousands of these fast, lightweight containers running on top of virtual machines just to get the best of both worlds. And to really drive home just how lightweight containers are, check out this number, 3.6. That is 3.6 megabytes. That's the absolutely tiny size of an Alpine Linux container image. Contrast that, beautifully, against traditional virtual machines, which are usually measured in dozens of gigabytes. No wonder containers can boot up almost instantly. Part 4. Essential Docker commands. So the absolute most common command you're going to use is Docker run. When you type this into your terminal, a pretty cool 3-step magic trick happens seamlessly under the hood. First, Docker checks your local machine for the requested image. Second, if it can't find it locally, it automatically reaches out to Docker Hub, which is this massive public registry, and pulls the image down for you. And finally, it creates and runs that completely isolated container instance. All of this happens in literally seconds. Now, since containers are explicitly designed to be temporary, managing them and cleaning them up is just a totally normal part of your daily workflow. Here's a quick little cheat sheet for you. Use Docker PS to list all your currently running containers. Need to halt one? Use Docker Stop. Want to permanently remove a stopped container so it stops cluttering up your system? Use Docker RM. And to delete a saved heavy image from your host completely, you use Docker RMI. It's really incredibly straightforward to keep your environment pristine. But here is a fascinating question you might be wondering. If these containers are completely isolated from your main system with their own internal networks, how do outside users actually reach your web application? Like, how does the web traffic actually get inside the box? Part 5, Ports, Tags, and Terminals. The answer to our networking question is a concept called port mapping. By using the -p parameter, you can selectively forward traffic from your underlying Docker host right into the isolated container. For example, you could map your host's public port 80 directly to the container's internal port 5000. So now, when a user types your server's IP address into their web browser, the traffic seamlessly flows directly into your isolated web app. Let's build out your command line fluency a bit more with some super useful run flags. You're almost always going to use the deflag or detached mode to let a web server run quietly in the background, instantly giving you your terminal prompt back. But what if you actually want to interact with the container? Well, you combine I for interactive standard input and T for a pseudo TTY. Using IT together effectively tricks the app into thinking it's talking to a real terminal, giving you a fully colorful interactive command prompt right inside your isolated container. Okay, here is a critical pro tip for when you take this knowledge to production. Always pin your image versions. You want to use something highly specific, like Redis 7.4, instead of blindly relying on the default latest tag. The thing is, the latest tag is a constantly moving target. If the upstream authors push a new update with breaking changes, your container might quietly upgrade under you the next time you deploy, pulling the rug right out from under your production app. Pinning your versions guarantees absolute stability. So let me pose a slightly scary question. We've firmly established that containers are ephemeral, and they have their own tightly isolated file systems. So if a database container crashes, dies, or just gets deleted by a Docker RM command, what happens to all those precious database records stored inside it? Part 6, Persisting Data with Volumes. Let's lay this out in pretty stark terms. Without volumes, absolutely all data generated inside a container is permanently destroyed the exact moment the container is removed. So, if you have a MySQL database running and you delete that container, all your tables, all your user records, they literally go down with the ship. Completely, irrevocably wiped clean. The absolute lifesaver here is a concept called volumes. By utilizing the v or -mount flags, you can effectively poke a controlled hole through the container's isolation. You map a safe, permanent directory on your host machine, like ops/datadir, directly into the container's internal file system. Because of this clever little bridge, the database writes its files safely to the host machine. That means if the container crashes or gets deliberately replaced, your data persists completely unharmed, just waiting to be attached to the next container you spin up. And just like that, you have officially escaped the matrix from hell. You now thoroughly understand images, containers, basic management commands, internal networking, and persistent volumes. So now that you hold the power to instantly deploy virtually any application imaginable with a single, simple command, what are you going to build first? It is time to open up your terminal, pull an image, and start exploring. Thanks so much for joining me in this explainer, and happy building.